go over the problems from section 12.2 that I did not go over in the notes with you guys. And we're going to start with number 8. Notice on number 8 we are given the vertex form. If you're given the vertex form, you can find the vertex. Your vertex form in general is y equals a times x minus h squared plus k, and your vertex is h comma k. And so looking at what I have here, h is the opposite of 3 here, which is negative 3, and k is the negative 8. So in the formula you have x minus h squared, so you take the opposite of h to get that value. So if h is negative 3, the opposite of negative 3 would be a plus 3, and so you have in the equation x plus 3. So that plus 3, to get to the h, going backwards, you take the opposite of plus 3 to get your negative 3. So you're always, whatever's in parentheses with the x, you're always going to take the opposite of that when you're getting the vertex. So I got my negative 3 and k is negative 8. You're not taking the opposite of the negative 8, you're just leaving that put. Alright, so we have a vertex. We're still in need of some other pieces. So if you're given vertex form, you can easily get into standard form just by multiplying everything out. And so that's what I'll do here. I'm going to rewrite the vertex form. Y equals 2 times x plus 3 squared minus 8. And then work through this and follow order of operations. So exponents first, so we got 2 times x plus 3 times another x plus 3 minus 8. When you multiply, you can multiply the 2 times one of the x plus 3's. You can't, not both. Or you can multiply x plus 3 times x plus 3 first and then multiply the 2 in. I'm just going to multiply the 2 in only into the first one, not the second one. And I get y is 2x plus 6 times x plus 3 minus 8. And then continue to distribute. 2x times x is 2x squared. 2x times 3 is 6x, positive. 6 times x is another 6x. And 6 times 3 is 18. And don't forget the minus 8. And now combine like terms, and you get 2x squared plus 12x, and then 18 minus 8 is 10. So that is your standard form. And from your standard form you can get your y-intercept. You just plug in 0 for x, and you get everything with an x goes to 0, and you're left with just the constant. So y is going to end up being 10 when you plug in x into that equation. And so my y-intercept is 0, 10. We get factored form by factoring standard form. So let's do that next. So we have y is 2x squared plus 12x plus 10. I'm noticing all terms are divisible by 2. So I'm going to factor out of 2. I'm left with x squared plus 6x plus 5. And now I'm looking for two numbers that multiply to 5 times 1, which is 5. So 5x squared, and adds to 6x. And I'm going to use let's go 3 and 2. So 3x times 2x is 5x. Sorry, that's not true. I'm thinking backwards here. what we're going to do, we're going to go with 5 and 1. So 5x times 1x is going to multiply to 5x squared, and we'll add the 6x. So we have y is 2 times, and split this up to 4 pieces. So we got x squared plus 5x plus 1x plus 5. And factor by grouping. I factor an x out of the first two terms here, and I get x times x plus 5 plus factor 1 out, and I'm left with another x plus 5. Keep going. 2 times, if you look at both of these terms, they both have an x plus 5, so factor out the x plus 5, and we're left with an x plus 1. And now we have factored form 2 times x plus 5 times x plus 1. And from factored form, you can get your roots easily. Set y equal to 0 and solve. And since it's already factored, you just take your factors that have x in them and set those equal to 0. So x plus 5 and x plus 1 equals 0. And solve for x. And you get x is negative 5 and x is negative 1. And from your roots you get x-intercepts. So negative 5 comma 0 and negative 5 comma negative 1. Your line of symmetry is always right in between your two x-intercepts. And I made a mistake on my x-intercept, sorry, let me fix that. So my line of symmetry, if I average my x values, I have a negative 5 plus a negative 1 divided by 2, which is negative 6 over 2, which is negative 3. So x equals negative 3 is the center, or the line of symmetry. You also know that your x value for the vertex will also be the same x value for the line of symmetry. So there's a few different ways to get that line of symmetry. Alright, we have a lot of information here. Let's plot the points. Let's see what we can do here. So my line of symmetry is right here. I have an x-intercept at negative 5, 0, and an x-intercept at negative 1, 0. I have a vertex at negative 3, negative 8. I have a y-intercept at 0, 10. And notice that y-intercept is 2 to the right of my axis of symmetry. So if I go 2 to the left of the axis of symmetry, I get another point that's the same height because it's symmetric. I'm sorry, I said 2, I meant 3. The 0, 10 is 3 to the right, so if I go 3 to the left, so that would be negative 6, 10. I have 5 points. I'll put all those here. So it's negative 6, 10, negative 5, 0, negative 3, 8, sorry, negative 8, negative 1, 0, and 0, 10. Domains, all real numbers. Right now that's what it's going to be for all parabolas until we get into more word problems or contextual problems. The range, the lowest this goes is at negative 3, negative 8. So negative 8 is the lowest. You look at y values. Domain's about the x, range is about the y values. So all y values bigger than or equal to negative 8 is the range of this parabola. As you trace this parabola from left to right, first it drops, so it's decreasing until it gets to negative 3, the axis of symmetry. So it decreases when x is less than negative 3, and then it increases when x is greater than negative 3. Okay, question here, and please make sure you answer these questions on your homework. It says, how can you tell if the graph of a parabola will have a maximum or a minimum just by looking at one form of its equation? So if a is positive, okay, and a is the number in front of x squared, then, and we said this in our last time we went over our homework on 1 through 6, if a is positive, then the parabola opens up. Well, if the parabola opens up, that means the vertex will be a minimum. So, and the vertex will be a minimum. A minimum just means the lowest value. Okay, so if a is positive, parabola will open up, vertex will be a minimum. If a is negative, and again, a you can see on all three forms. A is like on number 8, if we look at the standard form, a is 2 because you have 2x squared. If you look at factored form, you can see a is your leading term here, 2. Factored form sometimes can hide a, but you can always think, well, if I were to multiply factored form out, what would I get in front of x squared? And then vertex form will always show a. A is what's in front of the x minus h squared. So if a is negative, then the parabola opens down. And the vertex will be the highest value, which is the maximum. Alright. Some of you may be wondering, well, what if a is equal to 0? If a is equal to 0, then there will not be an x squared term, and then you will not get a parabola. So if you have a parabola, then a either has to be bigger than 0 or smaller than 0, and we've hit all our cases here. Alright, next problem, number 10. And 10, we're given standard form, and that's it. And we gotta find out everything else. So first of all, if I plug in x, or plug in 0 for x, I get 4 times 0 squared, which is 0. I get 8 times 0, which is 0. All that's left is that 3. So I get y is 3. So that's my x-intercept, 0, 3. And now let's try to factor this. So I'm looking for two numbers, or two terms, who multiply to 4x squared times 3. So you multiply the first term and the last term together and get 12x squared. And then the middle term, 8x, is what I want my two terms to add up to. So I want the sum of these two terms to be 8x, and I want the product to be 12x squared. So I start thinking, well, what times what is 12? And 2 times 6 is 12. And then I ask, well, does that add up to 8? Yes, it does. So 2x and 6x will be the two terms I was looking for. And that's going to tell me how to split up my 8x. I'm going to split that up to 2x and 6x. So I'm trying to factor, and this is the method I'm using here, right? So you got 4x squared stays put. The 8x becomes 2x plus 6x plus 3. So we've split those three terms into 4 terms so that we can now factor by grouping. So I look at the first two terms and ask, what can I factor out of the first two terms? What is the greatest common factor? And I can factor out a 2x, and I'm left with 2x plus 1. And I look at the last two terms, I can factor out a 3, and I'm left with 2x plus 1 again. And notice these two terms both have a 2x plus 1, so I factor out the 2x plus 1, and I'm left with the 2x plus 3. And that's factored form. So that's what I'm going to put over here. And once you find factored form, you can get your x-intercepts by letting y equal 0 and solving for x. Since it's in factored form, we solve, and it's equal to 0, you take your factors that have x in them and set those factors equal to 0 and solve. And we get x is negative 1 half, and x is equal to negative 3 over 2. So my x-intercepts, got two of them, negative 1 half, 0, and the other one is negative 3 over 2, 0. Now from your x-intercepts, you can find the line of symmetry by averaging your x-intercepts. So if I take negative 1 half and add it to negative 3 halves, and then divide that by 2, that's how you average. That gives me the line of symmetry. So keep doing that. I get negative 4 over 2 over 2. Negative 4 over 2 is negative 2. And negative 2 over 2 is negative 1. So my line of symmetry is x equals negative 1. Which now, since I know the line of symmetry, I know the first value of my vertex, x equals negative 1. To find my y value for the vertex, I plug in negative 1 into an equation that I have, and I can do standard form, or I could plug it into factored form. I'm going to change colors here, and I will plug that into factored form. So if x is negative 1, then y is going to be 2 times negative 1 plus 1 times 2 times negative 1 plus 3. So I'm plugging it into factored form. Again, you could plug it into the other form as well, and I get negative 2 plus 1. Negative 2 plus 1 is negative 1 times negative 2 plus 3, which is positive 1. So negative 1 times positive 1 is negative 1. So vertex is negative 1, negative 1. So I know H is negative 1, K is negative 1, and then A is the other piece I need for vertex form. A is the number in front of x squared in standard form, which is 4. So when I write this out, I write y equals 4 times x plus 1. It's the opposite of h. H is negative 1, so I do the opposite of h, which is plus 1 squared, and then minus 1, which is k. And that's your vertex form of the equation. So I have all three forms: standard form, found vertex form, found factored form, and vertex form. Let's put everything in a graph now. So my y-intercept is at 0, 3. The axis of symmetry, the middle is at 1. I'll put, negative 1. So this is the middle of the graph. So that's, if I go, so my y-intercept is 1 to the right of the middle, so if I go 1 to the left of the middle at negative 2, I'm going to have something the same height. It matches it, because it's symmetric. So negative 2, 3 will be another point, and I just get that from symmetry. Negative 1 is our vertex that we found, so put a point there for the vertex. And then we have an x-intercept at negative 1/2, 0 right here, and at negative 3 over 2. Negative 3 over 2 as a decimal would be negative 1.5, and so negative 1.5 is between negative 1 and 2, so something like this. And I got 5 points. Negative 2, 3, negative 3/2, 0, negative 1, negative 1, negative 1/2, 0, and 0, 3. Domain, what x values can we plug into this equation? All of them. Range, well, it has a lowest point. A is positive, so you see our parabola is opening up, and it has a minimum, which is our vertex, and the lowest value is at negative 1, so all y values bigger than or equal to that lowest value, negative 1, is our range. As you trace this from left to right, it's first dropping or decreasing till it gets to the middle, so all x values less than the middle, negative 1, the axis of symmetry, will be decreasing. Anything past that starts to increase. And that's number 10. Last one I want to do with you is number 12. 12 we're given standard form, and so if I plug a 0 in for x, Negative 16 times 0 squared is 0. I'm just left with 1. So my y-intercept is 0, 1. Then I'm going to factor this. So I'm going to first factor out a negative 1. I'm left with positive 16x squared minus 1. Notice this is a difference of two perfect squares. 16x squared is 4x times 4x, 1 is 1 times 1, and it's a minus sign in between them, so I can factor using the shortcut for a difference of two squares. And I get 4x plus 1 times 4x minus 1. So that's our factored form. Y equals negative 4x plus 1 times 4x minus 1. We can find the x-intercepts by setting y equal to 0. And solving. And when it's factored and it's equal to 0, you just take your factors that have the variable you're looking for and set your factors equal to 0 and solve. And we end up with x is negative 1/4 and x is equal to positive 1/4. So my x-intercepts, negative 1/4, comma 0, and positive 1/4, comma 0. From your x-intercepts, you can get your line of symmetry by averaging these. 1/4 plus negative 1/4 divided by 2, which is 0, over 2, which is 0. So my line of symmetry is x equals 0, which ends up being your y-axis. My vertex is 0, comma something. And we already know from the y-intercept that if you plug in 0, you get 1. So your vertex here and your y-intercept are the same, which makes sense since the y-axis is the line of symmetry. And so h is 0, k is 1, and a is negative 16. And I'm getting that from standard form. You see the negative 16 in front of the x squared. So putting that together, you get y is equal to negative 16 x minus 0 squared plus 1, which is the same as negative 16 x squared plus 1. And let me let you in on a little secret here. And maybe let's just write it down here, add it to our notes. So if standard form does not have a linear term, and a linear term is the term that has the x value. So in our case here, if I write y equals ax squared plus bx plus c, we call the ax squared the quadratic term, the bx is your linear term, and c is what we refer to as the constant. So if you're missing a linear term like we are in number 12, then your standard form is the same as the vertex form. line of symmetry will always be x equals 0. So right off the bat, if you're working with something that's in standard form, you see it's missing the linear term, you know you have vertex form, you know the line of symmetry is going to be at 0. Alright, let's put some of this in a graph. Okay, so our vertex is at 0, 1. Our x-intercepts are at 1/4, 0, and negative 1/4, 0. And so we only have 3 points, we need 2 more points. And so if you don't have any other points, which we don't in this case, you just pick a value and plug it in. So I'm going to plug in 1. So let's see here. I'm going to add these to my graph, sorry, my table first. So we have 0, 1 is the middle of our graph. We have a negative 1/4, 0, and a positive 1/4, 0. And I'm going to let x be 1. You can plug in anything you want for x. I'm just going to pick something that that's small enough where I can put on my graph. So if I plug a 1 in, I'm going to use standard form here. I got y equals negative 16 times 1 squared plus 1, which is negative 16 plus 1, which is negative 15. So 1, negative 15. And so I'm just going to put a point here, call it 1, negative 15. And there's going to be a matching one over here at negative 1, 15. Negative 15, sorry. Sorry, it's not a really smooth looking graph here. Something like that though. Make sure my table's all filled out. And now the domain, all real numbers. Right now we can plug in anything we want for x. That will change when we talk about word problems. Range, the highest value, the maximum, is at a y value of 1, so all the y values has to be under or equal to 1, less than or equal to 1. As we trace this, we start by increasing, so we're increasing when we're on the left side of the graph, or when x is less than 0. We're decreasing on the right side of the graph, so when x is greater than 0. And I think that's the last one for the homework. So you should have seen between the notes and the homework all the problems worked out. Hope things are going well for you, and that's it.